Alright, so today we're going to continue completing the square. The only difference today is that we're going to see problems where the a value is not 1, okay? So if the a value is not 1, let's say it's 2, 3, 1/2, 7, whatever, before you can use the b divided by 2 squared formula, you will have to make a become 1 by dividing each term by a. So if we see a 2, we'll divide everything by 2 on both sides of the equation. If we see a 3, we'll divide by 3 and so on. And then we'll solve just like we did before. Okay, but the b divided by 2 squared formula, this only works when a is 1. So we have to make a become 1 before we can use that process. Otherwise it won't create a perfect square trinomial because 2 is not a perfect square. So we do see that we have a value that is not 1. So we're going to have to divide by 2 everywhere. Here, here, and here. So 2 divided by 2 gets me 1x squared plus 1/2 x. I'm going to go ahead and put in my plus blank at that point, just so I remember. You could do it on the next line, but and then that equals 6 divided by 2, which is 3. And I'll put my plus blank. Make sure you do it on both sides. You have to be consistent and balance your equation. All right, once you do that, this now becomes my a. This is my b. This is technically my c, which you don't need. Whenever you're doing your b divided by 2 squared formula, you want to use the new value of b, not the original one. Okay, so I'm going to find out what I'm plugging in here and here. Now I'm going to get 1/2 divided by 2. Squared. What is 1/2 divided by 2? Okay. 1/4. Okay, the 2 kind of just drops down and gets multiplied with the denominator, but the reason for that, if you were taking 1/2 divided by 2, you would change division to be multiplication of the reciprocal, which would get us 1/4, which is why that works. Okay, but really this kind of just goes down and gets multiplied with the denominator. You want to show the work for this, because again, that's going to help you factor it in the next part to know what goes in the parentheses. Now we'll square the top and the bottom. 1 squared, 4 squared, I'm going to get 1/16. So that's what I'm adding to both sides. Now again, when we go to factor the left side, it's going to come out to be something squared. Again, to know what number we're plugging in here, all you have to do is go back up and look at what you had before you squared it. So we had a positive 1/4, so it must be a plus 1/4. And if you're not sure, you can always check this. To make sure that it works by foiling. X squared plus 1/4 plus 1/4, which would be 2/4, which is 1/2, and then 1/4 times 1/4 is 1/16. So if you're not sure, just mentally foil it to make sure you're doing the right thing. All right, over here we would need a common denominator, which would be 16. So we'll get 48/16 plus 1/16. Which will get me 49/16. And then we would solve by square rooting and inserting our plus or minus right when we do that. So square and square root undo one another. Now each of these is a perfect square, right? 7 and 4. So no rationalizing, no simplifying radicals needed, just take your square roots. And then it's up to you. If you notice, these are both fractions. You can either set up two equations, setting one equal to positive 7/4 and one equal to negative 7/4, or you can move it over and then split it up. I don't care how you do it. A lot of you will do this. You just don't want to leave that as your final answer because they are able to be combined. So we would actually do negative 1/4 plus 7/4 and negative 1/4 minus 7/4. And you could do this in your head, just adding and subtracting. Negative 1 plus 7 is 6/4, which is 3/2 or 1.5. And negative 1 plus minus 7, excuse me, is negative 8, which is negative 2. Based on the answers, this would have been factorable had we have tried to factor it. Okay, but a lot of times they'll come out to be imaginary numbers or square roots. You'll do the process exactly the same. Okay. 2 more to take a look at. Now you do still need to get it in the form ax squared plus bx equals c. And you could do that before or after you divide by k. But some students like to do that first. So let's go ahead and add 7x to both sides. I'm not going to put my plus blank yet because I'm going to have to get rid of the 2. But if you put it, it's in here. If this is not 1, you have to make it become a 1 by dividing everything by this factor. So we'll divide by 2 everywhere. Then the x squared. Again, you will want to leave this as a fraction. You don't want to make it 3.5 because then you're going to have to do 3.5 divided by 2 and square it, possibly without a calculator. So fractions are easier. At this point, I will add in my plus blank on both sides. Now we're going to figure out what that blank is. Again, using this value as your b, the new b. So we have 7/2 divided by 2. One mistake I'll see a lot of you make is that you forget to put the other divided by 2. You'll just have 7/2 squared. So make sure you have that. This again will kind of go down and get multiplied to get a 7/4 squared. Square the top, 49. Square the bottom, 16. On the left, we're going to factor that down, again, to know what it factors into. Just look at what it was before you squared it. It's a positive 7/4, so that has to be a plus 7/4. And then we will need to make a common denominator here, which would be 16. So I'll multiply by 8. And I'll add those together to get 57 16ths. Square root both sides. And put in our plus or minus. Now here you might want to split up your square roots to be square root of 57 over the square root of 16. Only one of those is a perfect square, and that's our 16. That'll become a 4. Is 57 reducible? So divisible by 4? 9, 16. No, so this one can't be simplified. We'll just leave it. The square root of 57. But we will need to move the 7/4 over. So subtracting 7/4. And negative 7/4 plus or minus the square root of 57. Again, the answer key from the book may write this as one fraction. I don't care how you write it, if you leave it separately or if you combine. Now make sure you realize if these did have different denominators, you would have to find a common denominator before you combined them. But in that case, we can leave it like that. Alright, why don't you guys try example B? I'll be walking around. If you need some help, just raise your hand.